Okay, the next technique that I'm going to go through that you need for circles questions is the technique we did way back in September, October time, which is solving simultaneous equations where one is linear and one is quadratic. Okay, on the board I've put a quadratic equation, x squared plus y squared equals 25. I've put a linear equation, 2y plus x is equal to 10. Here we go. I'm going to label the quadratic one number 1 and the linear one number 2. The technique, if you remember, involves taking the linear equation and restructuring it to get either y or x as the subject of the formula. Well, here we go then. Equation 2 becomes the following. I would suggest, because it's 2y and it's only plus 1x, it would be easier to get the plus 1x on its own. So I'm going to leave the plus x on the left on its own. That's going to be our new subject. And take the 2y over. So you get x equals 10 minus 2y. I'll call that equation 3. All you've got to do now is take equation 3, which is x equals 10 minus 2y, and substitute it into the quadratic one which we haven't yet used, which is equation 1. So equation 1 is going to become the following. Everywhere I see an x, therefore I'm now going to change it to 10 minus 2y. So the quadratic, instead of x squared, becomes 10 minus 2y in a bracket squared plus y squared is equal to 25. And as you can see, that's a quadratic equation in just the variable y. There's no x's anymore. The x's have disappeared. Okay, we need to solve this, which means we've first of all got to get rid of that bracket squared. So let's expand that out. You square the first, you get 100. Multiply the two together, you get minus 20y. You double that, you get minus 40y. You then have to take the second term, which is minus 2y, and you have to square that. Minus 2y times minus 2y is positive 4y squared. The plus y squared still remains unchanged, as does the 25 on the right hand side. Let's just tidy up. 4y squared plus y squared go together to give 5y squared. We'll put it down first because the y squares will go first. There's only minus 40y as a y term, no other y terms, so just write that straight down. And then the numbers, we've got a positive 100 on the left, take the 25 over, it becomes a minus, so you get positive 75 equals 0. We now have the quadratic in the right format. Y squared y's number equals 0. Before you try factorise the left hand side, remember, make it easy, share by 5. Share by 5, y squared. Share that by 5, take away 8y. Share that by 5, you get plus 15. You share that by 5 as well. The 0 when you share by 5 just remains as 0. So we get this equation coming out, which is much easier to factorise. The left hand side does not have a common factor, so we're going to do it by, well, inspection method. If it's a y squared, it must be a y with a y. So this number multiplied by this number gives you a positive 15. Well, that means they're either both negatives or they're both positives. Well, if it's a negative 8y in the middle, it must tell you they're both negatives. And if you think about it for a second, it's got to be 5 3's, because 5 3's make 15, and then if you put minus 5y with minus 3y, they combine minus 5, minus 3 to give the minus 8 in the middle. So there's the factorisation. So you're getting that either the first bracket equals 0, in which case you first get an answer y equals 5, or alternatively the second bracket y minus 3 equals 0, in which case you get a second answer for y, it can be 3. So you get two possible answers that y could be, and as a result of that you're going to get two possible x answers that go with them, so you get two pairs of answers, two pairs of solutions. Okay, if I go over here, cordon this bit off, for each one of these in turn I'm going to work out what the x value to go with them is. So if y is 5, go back to equation 3, you can see that x is equal to 10 minus 2 5's. So x turns out to be 10, take away, that's 10. 10 take away 10 is nothing. And I'll just pair the two answers together then. If y is 5, x is 0. Okay, so x 0, y is 5, in a bracket, there's your first solution. So if you were to put x equals 0 to y equals 5 in both of those equations, it would solve, or it would satisfy them simultaneously. They would work. Okay, there's a second pair of answers. So if y equals 3, we can work out that x will be equal to, from equation 3, 10 take away 2 3's. 10 take away 2 3's. So y is 3 in this case. And 10 take away 2 3's, that's 10 take away 6. X turns out to be 4. So the second pair of answers, x equals 4, y equals 3, is your second solution. So if you put x equals 4 into this and y equals 3 into this, it would work for equation 1 and it would work for equation 2. It works for them both simultaneously. There you go, that's the basic technique that we did in September on solving one linear, one quadratic simultaneous equations.